Hello, my name is Thiemo Wambsganss and I'm a PhD student from the University of St. Gallen in Switzerland, and today I'm presenting you our research project about an adaptive learning support system for argumentation skills. We worked on that project with two groups from the University of St. Gallen, the Information Systems Institute and the Computer Science Institute with the research group on natural language processing by Siegfried Handschuh. Before I start the presentation, I want to start with a small anecdote. And basically what we see today in discussions of conferences or as a discussion with students is that factual knowledge is not the only reason to convince somebody from your statement or to convince the opponent from something, right? It's rather the organization of your knowledge and organization of the facts, the lines of argumentation which convinces somebody or which makes your statements persuasive. This is reflected that knowledge is not only anymore accessible for a limited group of people, since it was stored in like large books in big libraries and only accessible for monks or kings, right? But it's basically available for everybody and can be all the time, around the clock, looked up via smart devices. You can Google facts, statistics, and so on, and thus make a discussion more elaborated with your facts. So the importance of argumentation skills for to persuade the opponent or for also leading negotiations is also reflected in the OECD Learning Framework 2030, which named metacognition skills as the 21st century learner, important for the 21st century learner, right? So not only they say that governments should not only focus to build like knowledge, like factual knowledge in the education of their students, but also focus on developing skills such as problem solving skills, communication, or also argumentation. One of these skills is argumentation. In order to teach argumentation, we know from learning theory that adaptive feedback and adaptive tutoring in the learning process is a necessary condition for students to learn how to argue. However, this is traditionally or was always very hard to do, since we don't have like this one-to-one relationship between tutor and lecturer, but rather we have like a 1-to-20 or even a 1-to-100 relationship in traditional large-scale lecture scenarios. Besides that, the number of students is always growing, such as reflected here in Germany or the USA in the last years, and we have a rapid number in distance learning scenarios such as massive open online courses, where you have very unequal student-lecturer relationships, right? So our hypothesis was, can we leverage recent advantages in human-computer interaction to provide students with adaptive learning supports based on natural language processing or machine learning to help them to learn how to argue independent of an instructor, time, and place. To know what is good argumentation, I firstly want to give a background on that. So argumentation is like the way how we communicate in our daily life, how we think, and how we transport knowledge. The basic notion is, if you follow an argumentation model, is that you have like two components. There's a claim, which is your statement, what you claim, and a premise, like a fact or interpretation to support this claim. And the argumentation models say, if you follow this formal structure of argumentation, your statement should be more persuasive than if you don't follow that, right? So if you don't give an example, you're less persuasive than if you give like a fact or an example to your claim. Other argumentation models, for example, of Tolman, are more elaborated, right? Tolman distinguishes between 6 different parts of arguments. And also with the same notion, if you follow this argumentation structure, you should be more persuasive than if you don't follow. These argumentation structures can be analyzed by recent advantages in natural language processing and machine learning in a field called argumentation mining. So argumentation mining extracts argument components, argument relations, and discourse structures from texts, and is, for example, used in the legal domain for legal texts or for user-generated content. And our hypothesis was that we can use maybe this advance in this technology to also provide students with feedback on argumentation in texts. So the basic idea we had was a student writes a text independent of an instructor, time, and location, and receives feedback from a system on his argumentation, and thus building on cognitive dissonance theory, which you can also further read in the paper. Students would construct new knowledge based on this dissonance, and then learn how to argue. To follow up on this idea, we followed a theory-driven and user-centered design. We firstly accessed like different knowledge in systematic literature reviews in the knowledge base, and also derived knowledge from the user on how to design such a system, right? Since we want to build a user-centered system. So what we did first was conducting 30 semi-structured interviews with students, about 40 to 50 minutes. We asked them what are their challenges in learning how to argue at universities, what kind of feedback would they like to get on the argumentation of their text, and how should the tool be designed. Based on that, we derived different user requirements. Besides, we also did a fast iterating, rapid prototyping approach where we designed different mock-ups in forms of prototypes, and always iterated that with students to gain further design knowledge and how to design an adaptive learning support system. Based on the interviews, based on the theory we derived and the rapid prototypes, we derived different design principles. Here's, for example, one of the mock-ups. We had a requirement: student wanted to enter a text in text or audio, and they wanted to receive a feedback in the form of a personal learning dashboard where they get like structures about the argumentation in summarizing scores, and then they can dive into the argumentation structures by themselves and can decide themselves how they take the feedback, right? We summarized these findings in the first step as design principles, so to provide more knowledge on how to design adaptive support systems for skills such as argumentation skills, to also show other designers of such systems how they, for example, could transfer the knowledge to their systems. So the next step, in order to build like the fully working system, we needed to develop like the algorithm which extracts argumentation from student text and their relations, right? Since there was no suitable corpus in literature which was based on German texts and texts from students, we started to annotate our own texts. So for that, we wrote the annotation guide on 15 pages, did an annotation study with 3 annotators, calculate annotation scores, and then finally build a corpus of 1,000 student-generated peer reviews in German, which we could then use to build an algorithm to provide feedback on German written student texts. This was necessary since requirement from students was that the feedback should be really individual and should be really helping them to improve their text. So we had the adaptive front end here, which was called L, and we had a feedback algorithm back end, which was trained on our corpus with different machine learning algorithms. A student was then able to enter here a text on the left side in the text editor. Here text is about the feedback about a business model to a fellow student. And then after entering his statement, he can click the Analyze button, and he will receive an instant feedback on his argumentation. He can always click on explanation buttons to see what are argument structures depicted. For example, claims are in green, premises in yellow, and then he can get to know the system better, right? This was also one of the major feedbacks we got in the prototyping sessions. Then he can click on the argumentation on his text and see how are claims supported by premises. For example, here one claim is supported by 3 premises, indicating that it's very persuasive, right? We also incorporate a graph view from the user feedback to show the complete discourse overview of the argumentation of their text, so that students can also go through the graph and click on the argumentative components and dive into. Moreover, we had the summative scores, for example, how argumentative the text is, how is the readability or the coherence, and students receive different adaptive feedback messages based on the percentage of the scores, and could then elaborate for themselves if they take action. So now the students see that here's a claim which is not sufficiently supported by a premise, so it has no example, fact, or intuition. He goes to the text and he decides for himself that he will add an example here about this statement. This statement is now in German. It's about the transparency of this business model. And now he gives an example that the transparency is very important. During writing the text, there's like a small word count, which also helps like lecture scenarios. If you have like a certain amount of words students need to fulfill, and then you can click the analyze button again. The persuasive score now went up because he got like another argument supported, and he can see in his graph that the claim is now supported. To evaluate our hypothesis, if this adaptive feedback helps students to write better argumentative text, we conducted a laboratory experiment with 45 participants where they had to write a persuasive text. We relied on two groups, one treatment group which used our adaptive support system to write the text, and one control group which used an alternative proven scripting approach from literature from Fisher 2013, which is like an approach based on input mass, which is proven to help students to write better argumentation. We checked different randomization scores, such as we checked the argumentation level of the students before, and other different scores, such the openness for IT innovations, and later we checked different scores in the items in the post survey. For checking if the argumentation of the students were higher than in different texts, we focused on two main variables: on the formal quality of argumentation following the Weinberger and Fischer scheme from 2006, and we relied on the perceived quality of argumentation, since an argumentation is always some sort of how many formal arguments you have and how persuasive these arguments are. We annotated the students' text for these two scores, and we received the results that the formal number of arguments from students using our adaptive support approach was significantly higher than of the reference approach. And also on the right side, you can see that people wrote much more persuasive text with our adaptive support approach than with the reference tool. Not to confuse yourself, on the left side, the number it's the number of arguments, which is a higher number of arguments is better than a lower number, and on the second diagram, number 1 is better, since this was the score we used. 1 is very persuasive and 5 is not very persuasive. So these results indicate that our adaptive argumentation support approach helps students significantly to write better formal and perceived better argumentative texts. Moreover, we checked a lot of other scores, such as the technology acceptance model, where we received very good results for the ease of use, for the intention to use, and the perceived usefulness of our adaptive support tool, also supporting or indicating the usefulness of using such a tool in a real learning environment, since the technology acceptance is a very big factor for students to reliably use the learning tool. Not part of the... All in all, we contribute to the theoretical part, to theory and practice by giving like a first instantiation of our argumentation tool based on natural language processing machine learning to help students to better learn how to argue. We show lecturer how to embed the tool into a known learning scenarios, such as peer feedbacks, and we therefore contribute the OECD Learning Framework 2030 for a more metacognition skill-based education based on new forms of human-computer interaction. Thank you very much for listening. If you would like to contact me, feel free to write me an email or drop by in St. Gallen. I would be very happy to see many of you. And yeah, thank you very much. Goodbye.